Good afternoon to all of you. Welcome back to the mathematics class again. Hope that all of you are fine. Okay, we will start the class within 2 minutes. Okay, let some more people join. Okay. So again, we will continue with some more problems from the chapter integration. Okay, especially the questions asked in the last year, the board exam question paper. I have collected some questions from that question paper, and we will discuss those questions. Okay. Okay. So let us start the afternoon class. So I have taken some problems of integration from the previous year question papers, actually, the last 2023 board exam. Evaluate integral from 0 to pi by 2 log sin x minus log 2 cos x dx. Evaluate 0 to pi by 2 log sin x minus log 2 cos x dx. So this can be written as, first apply the property of logarithm. Okay. So this can be written as log of sin x divided by log of sin x divided by 2 cos x, isn't it? Log A minus log B equal to log of A by B. And that is equal to 0 to pi by 2, 0 to pi by 2, log of sin x by cos x is tan x by 2 dx. Log tan x by 2 dx. So put it as some equation 1. And also you can name this integral as some I, capital I. So after the modification, we have to apply the property of definite integral. Which property we have to apply? Everybody can give that property. 0 to a f of x dx is same as 0 to a integral from 0 to a f of a minus x dx, isn't it? So that property we can apply here. So using the property, also I, the same integral I, we can rewrite it as 0 to pi by 2 log of wherever x is there in the function, put pi by 2 minus x. That is the property says, no? Okay. If you want, you can mention that property just in bracket, okay? 0 to a, integral from 0 to a f of x dx is same as integral from 0 to a f of a minus x dx. This is the property what we have used. So after applying this property, this integral reduces to 0 to pi by 2, 0 to pi by 2, log of, what is tan pi by 2 minus x? Tan pi by 2 minus x is cot x. So you will get cot x by 2, log of cot x divided by 2 dx. Okay. Put it as equation 2. This integral, some equation 2. This is also, I remember, the same integral. After applying the property, the same integral converted, changed into log of cot x by 2. Now what to do? You just add it. Okay. You just add the equation 1 and equation 2. That means you will get, therefore, 1 plus 2. Equation 1 plus equation 2 implies. Equation 1 plus equation 2 implies 2i. I plus I, that is 2i. That's equal to integral from 0 to pi by 2. Integral from 0 to pi by 2. Log tan x by 2 plus log cot x by 2. Log tan x by 2 plus log cot x by 2. So remember the property. Log of x into y equal to log x plus log y. Remember? So log x plus log y equal to log of x into y. Okay. So we will apply that property. So that means log of x into y. So what happens here? First term is tan x by 2. Tan x by 2 into second next integral, the term is cot x by 2. So we have applied the property, na? Log x plus log y equal to log of xy. So 2i equal to 2i is equal to 0 to pi by 2 log of tan x into cot x is 1. Simple basic trigonometry. So tan x into cot x is 1. So 1 by 4 log of 1 by 4 dx. So now log 1 by 4 is a constant. Take it outside. So log of 1 by 4 into integral of 0 to pi by 2 dx. That is nothing but x. And integral of dx is x. And limit is 0 to pi by 2. Limit is 0 to pi by 2. So remaining thing everybody can do by yourself, isn't it? So 2i is equal to log 1 by 4. You can, if you want, you can write it minus log 4 also. Log of 1 by 4 is same as log 1 minus log 4. So that is minus log 4. Okay, log 1 is 0. And in the this is value, if you substitute the limit pi by 2 minus 0, that is pi by 2. So 2i is minus log 4 into pi by 2. So we need I. So what is I? So I is equal to divided by 2. So pi by 4. Minus is also there. So minus pi by 4 into log 4. Minus pi by 4 into log 4. Okay. If you want, you can further modify. Okay. Log 4 can be written as log 2 square. Log of, if you stop here also, you will get the mark. Anyway, we can modify. Okay. Log of 4 means log of 2 square. And log of 2 square means that is 2 log 2. So minus pi by 4 into 2 log 2. Integration is already over. Just we are modifying the answer. Minus pi by 4 into 2 log 2. Okay. So 2 will cancel. So minus pi by 2 log 2. Minus pi by 2 log 2. I equal to, I stands for the given integral. Okay. So I equal to minus pi by 2 log 2. Is it clear? Now look at this problem. Take this question. integral 1 upon root x into root x plus 1 into root x plus 2. 1 upon root x into root x plus 1 into root x plus 2. So have a look on this integral and identify which method can be applied. Okay, which method can be applied. It is not a definite integral, so there is no chance of any property. So we have to do some substitution or some idea. We have to identify. So what can be done here? So we can substitute root x in place of root x. We substitute t. Okay, in place of root x, we substitute t. That means the derivative of root x is 1 by 2 root x. Okay, so 1 by 2 root x into dx will be equal to dt. 1 by 2 root x dx will be equal to dt. Or 1 by root x dx equal to 1 by root x dx is equal to 2 dt. And in the given integral, you can see a 1 by root x in the denominator. So that 1 by root x and this dx, we have to take together. And the remaining portion, wherever root x is there, you have to put a t. Clear? So this will become t. So t plus 1, and here also t, into t plus 2. Okay, and 1 by root x dx will be dt. I think the remaining thing everybody can do by yourself. Okay, the method, once you identify the method, then the remaining will be very easy. Okay, so therefore the given integral, I'm not writing the whole expression again. The given integral is equal to integral of 1 by root x plus 1 into root x plus 2 into 1 by root x dx. We will just rearrange the terms. Okay, rearrange the terms. 1 by root x plus 1 into 1 root x plus 2 into 1 by root x dx. Just to rearrange the terms. So this is equal to, if you apply our substitution, that is equal to 1 by t plus 1. This is t plus 1 into t plus 2 into, what is 1 by root x dx? 1 by root x dx is 2 dt. Is it correct? So the remaining portion, everybody can do it. No? That's equal to, if you want, we can take the 2 outside. It is a constant. The remaining is 1 divided by t plus 1 into t plus 2 dx. So dt. So this integral, everybody is familiar with this integral. Apply the partial fraction. Directly you can express as a partial fraction and integrate it. Okay? Okay. Now look at this question. Zero to pi by 2 e raised to x sin x dx. Integral 0 to pi by 2 e raised to x sin x dx. I think there is nothing, no difficulties here. Everybody can do it. It's a direct integral. Okay, just identify the method actually. What method we have to apply here? Integration by parts, isn't it? Integration by parts. normal integration. Okay, integration by using the product rule, integration by parts. Then after getting the integral, apply the limit, isn't it? I think there is no need of any explanation for this answer now. And the second part also. Okay, the second part, I think it is a textbook problem only, but it's a question from the last year board examination question paper. Okay, both are. So textbook problem only, but it is something special. The method. Integral 1 by cos x minus a into cos x minus b dx. 1 upon cos x minus a into cos x minus b dx. Some of you may be knowing the method actually. Okay. So what idea we have to use? Any answer? Any comment? Multiply and divide by sine a plus b. Multiply and divide by sine a plus b. Okay. One response is here. Multiply and divide by sine a plus b. No other responses. Okay. So what we have to do is we have to introduce a term here. Okay. We have to introduce a term in the numerator. So I write the numerator as sine x minus a minus of x minus b. Or you can write the reverse way also, x minus b minus x minus, it doesn't matter. So that means ultimately what happens, x and x will cancel. So you will get sine of b minus a, sine of b minus a. So that term should be divided also. Sine of b minus a, we have to divide also. So 1 by sine b minus a. So in the numerator, we write sine of x minus a minus x minus b. X minus a minus of x minus b means that is b minus a only. Sine of b minus a. So actually, ultimately, there is no effect. There is no change in the given expression. And divided by same thing. And that is equal to, we have to expand it. We have to expand the numerator using sine a minus b. Okay, sine x minus y, yeah, sine of a minus b. So if we know what is sine x minus b, that is sine a cos b minus cos a sine b. Okay. Yeah, sine x cos y minus cos x sine y. Sine x cos y minus cos x sine y divided by cos x minus a into cos x minus b into dx. Okay. After that, we have to separate as two integrals, two parts. So 1 by sine of b minus a into divided by the denominator and separate it as two parts, two terms. So the first term will be sine x minus a divided by cos x minus a. Cos x minus b portion will be cancelling. Okay, common. So sine x minus a by cos x minus a, that means tan x minus a, tan of x minus a minus, and second term, cos x minus a into sin x minus b divided by cos x minus a into cos x minus b means cos x minus a will be cancelling, okay? The second part. So remaining is sin x minus b divided by cos x minus b, that is equal to tan of x minus b, tan of x minus b dx. So now the remaining is very simple. Integral of tan x we know. So tan x minus a also we know. No? Integral of tan means minus log cos x, yeah, log sec x. So both terms are now integrable. Okay, both are integrable. So write the integral. Now take this question. Evaluate 0 to pi by 2 modulus of sin x minus cos x dx. Modulus of sin x minus cos x dx. Integral from 0 to pi by 2 modulus of sin x minus cos x dx. So what to do? So before going to this problem, let us take the very simple so that you will come to know the idea. Suppose I want to integrate modulus of x minus 1, modulus of x minus 1. The limit is from 0 to 2. 0 to 2. Modulus of x minus 1 dx. So how we will integrate this function? If you know the idea here, almost the same idea we have to apply here also. Okay. So what to do? We have to apply the definition of mod x. Okay. So mod x minus 1 means the turning point is 1 actually. Okay. For less than 1, the function is negative of x minus 1, and greater than 1, the function is x minus 1. That is the definition of mod function actually. Mod x means for less than 0, the function is x only. For greater than or equal to 0, the function is, for less than 0, it is minus x, and for greater than or equal to 0, it is x only. And mod x minus 1 means the turning point is 1. Turning point is 1. So for less than 1, the function is minus of x minus 1. And for greater than 1, it is x minus 1. Okay, so 1 is the turning point. So like that here also, modulus of sin x minus cos x. So we have to see where we have to break that integral. Okay, so here in this question, we have to break at the point 1, 0 to 1, 0 to 1, where you have to take a minus of x minus 1. Okay, plus 1 to 2, there we have to take the same, x minus 1 only. Now the same idea, almost the same idea, we have to apply here also. So we have to break this integral as two parts, as two integrals. So sin x minus cos x is inside this mod symbol, na? Sin x minus cos x. So we have to see where the turning happens actually. Okay. So by definition, if I write modulus of sin x minus cos x, modulus of sin x minus cos x must be equal to, by definition of that mode function, this is equal to sin x minus cos x. Sin x minus cos x means same. If this is positive, yeah, sin x is greater than cos x. Positive means sin x is greater than cos x. And minus of sin x minus cos x, minus of sin x minus cos x if when this is negative. Okay, sin x minus cos x must be negative. That means sin x is less than cos x. Simply we are applying the definition of the mode function. Okay, mod x equal to x if x is positive greater than 0, and mod x equal to minus x when x is less than 0. The same idea here also. So sin x minus cos x if sin x is greater than cos x, minus of sin x minus cos x if sin x is less than cos x. So the given interval is 0 to pi by 2. 0 to pi by 2. So we have to see in that interval the nature of the sine and cosine cos function. Sine and cos function. I think if you know the graph of these trigonometric functions, very easily we can find. Very easily we can give the turning point. Okay. 0, pi by 2, pi, 3 pi by 2, and 2 pi. Okay. So we know sine 0 is 0, sine pi by 2 is 1, sine pi is 0, like that. We no need to draw the whole graph. Only we need up to pi by 2 only. Okay. And cos x, if you see the graph of cos x, cos 0 is 1, cos 0 is 1, and cos pi by 2 is 0. So up to pi by 2, if you take the graph, we can see that both are equal at the point pi by 4. You know? So less than pi by 4, less than pi by 4, you can see the graph of cos x lies above. Okay, cos x is more than, cos x is greater than sin x for less than pi by 4. That's the meaning. For less than pi by 4, cos x values are greater than sin x values. And for greater than pi by 4, greater than pi by 4, what happens? The sin x value is greater than cos x. Okay, for less than pi by 4, cos x is more than sin x, and for greater than pi by 4, less than pi by 4, cos x is more than, for greater than pi by 4, sin x is more. Okay, so pi by 4 is the turning point. Yeah, pi by 4 is the point where we have to break this integral. Okay, so now we can easily write the answer. Okay, this is equal to, we have to split at pi by 4, 0 to pi by 4. Okay, 0 to pi by 4, cos x is greater than sin x. Cos x is greater than sin x. That means what we have to take? Cos x is greater than sin x means this portion. No? So minus of sin x minus cos x. The other part, the second interval, that is pi by 4 to pi by 2. So greater than pi by 4. For greater than pi by 4, what we can see, sin x is more. Okay. So sin x is greater than cos x. Sin x is greater than cos x means in that interval, we have to take sin x minus cos x. Okay. So this is the important point. The remaining things are very simple. Everybody can integrate and substitute the limits. Okay. The problem, we should know how to break the integral as two parts. Okay. So for that, this graph will help you. Okay. At pi by 4, both are equal, you can see. And less than pi by 4, cos x is more than sin x. And for greater than pi by 4, sin x is more than cos x. Is it okay? I am seeing the chat. If nothing is there, okay, we'll continue. Okay. Okay, now take this integral, this question. integral of dx upon 1 by root of sine cube x into cos of x minus alpha. This is a question from the textbook only, NCERT textbook, and also asked in the last year board examination. Okay. So let us proceed. Okay. So what we have to do here? So inside the root, you can see a sine cube. Okay. Inside the root, you can see a sine cube x. So if it is sine raised to 4x, if it is sine raised to 4x, I can take that sine square x outside. No? So for that, what we will do, we will make this sine raised to 3, a sine cube, as sine raised to 4x. Sine raised to 4x into cos of x minus alpha. To make it balance, what we do, we divide by the sin x, divide by sin x. So multiplying and dividing by sin x. Okay, the term inside the root, we have multiplied and divided. You will come to know why we are doing all these things. Okay. Now, this sin raised to 4x, the root can be taken outside. So we know the root of sin raised to 4x is sin square x. Okay. Root of sin raised to 4x is sin square x, and 1 by sin square x means that is cos square x. Okay. So that we can do at a time. Okay. So sin square x will come outside in the denominator. So 1 by sin square x means cosec square x. So cosec square x dx all divided by root of, what is inside the root now? Cos x minus alpha divided by sin x. Cos x minus alpha. Cos x minus alpha, you expand it using the identity. Cos of x minus alpha is cos x cos alpha plus sin x sin alpha all divided by sin x. Okay. So that is equal to integral cosec square x dx. Cosec square x dx. You remember, in the numerator, we have got a term cosec square x. Okay. So naturally, our next target is to bring a term which is like cot x, because the derivative of cot x is cosec square x. So cosec square x is ready to receive a term like a cot x. Okay. So for that, what we do, you just divide by sin x throughout this expression in the root, inside the root. So what we will get? Cos x by sin x means cot x. Okay, cos alpha into cos alpha. Cos alpha is a constant actually. Cos alpha into cot x plus next term sin x sin alpha by sin x means sin x will cancel. So only sin alpha will be remaining. Now you see the term what we are searching for. Okay, that is now ready in the denominator. Cot x is there, no? So derivative of cot x is cosec square x, and cos alpha, sin alpha both are constant, some numbers actually. Okay, alpha is a constant. So cos alpha, sin alpha are some numbers. So we can put the everything inside the root, whatever it is there, we can put it as some t. Okay. So I will do the substitution here itself. So put the term inside the root, that is cos alpha cot x plus sin alpha, everything is equal to t. Cos alpha into cot x plus sin alpha is equal to t. So what is the derivative of this one? Therefore, if you take the derivative, cos alpha is a constant. Cot x derivative is minus cosec square x. So minus cos alpha into cosec square x. And sin alpha is a constant, so 0 only. So minus cos alpha cosec square x dx is equal to dt. Okay. We need actually cosec square x dx actually. In the integral, there is cosec square x dx. But cos alpha is a constant. So, okay, you can take in the other side. So minus cosec square x dx will be minus dt by cos alpha. Cosec square x dx is equal to minus dt by cos alpha. Now apply this substitution in this integral. So cosec square x dx reduces to minus dt by cos alpha. Cos alpha is a constant, so we can take outside the integral divided by root of everything inside the root is t actually, t. Okay. Now I think the remaining thing you can do. This is a very simple integral. So everybody can write, isn't it? After getting the answer in t, we have to substitute again what is t. Okay. So now let us take integral. Find integral e raised to cot inverse x into 1 minus x plus x square divided by 1 plus x square. E raised to cot inverse x into 1 minus x plus x square divided by 1 plus x square dx. So have a look at this question and identify the method. If anybody has got the idea, you can put in the chat box. Think about it. Okay. So got it? So here we have to make a substitution. Cot inverse x equal to t. Okay. Let's do the substitution cot inverse x equal to t and see what happens. Okay. So cot inverse x equal to t. That means x equal to t. X equal to cot t. That means dx equal to minus cosec square t into dt. Dx equal to minus cosec square t into dt. Now apply these substitutions in this given integral. So what happens? So given integral equal to integral e raised to Cot inverse x. Cot inverse x means t. E raised to t into, in bracket, 1 minus x means cot t. Cot t plus x square. X square means cot square t divided by 1 plus x square. 1 plus x square means 1 plus cot square t, 1 plus cot square t into minus cosec square t. Minus cosec square t dt. So that is equal to integral e raised to t in bracket. You can see the denominator is 1 plus cot square t, that is cosec square t. And in the numerator also you can see 1 cosec square t. So both will be cancelling. Okay. So this 1 plus cot square t and this cosec square t, both are same, will be cancelling. Then inside the bracket in the numerator, 1 plus cot square t. 1 plus cot square t, that again we can write it as cosec square t. 1 plus cot square t is cosec square t minus cot t. Okay. And again one minus is there. Okay. Into minus 1 is there. Now we are almost reaching the answer. Okay. Now you might have got the answer actually. So minus you can multiply inside this bracket terms. Okay. So cot t will be coming together. Cot t minus cosec square t dt. No? Cot t. Otherwise, again, if you want, we can write like this only. Okay. To get more clarity. E raised to t, integral of e raised to t into cot t plus minus cosec square t dt. Now, do you remember some formula? Some standard integral formula is there. If you remember that formula, immediately we can write this answer. Isn't it? What is that formula? There is a formula, something similar to this one. Integral e raised to x into f of x plus f dash x dx is equal to e raised to x f of x plus c. Isn't it? So you can see this is exactly of that form. If you take cot t as f of t, then its derivative is here, minus cosec square t, f dash t. Okay. So it is of the form e raised to t into f of t plus f dash t dt. So directly apply the formula. So what is the answer? What is the answer? E raised to t into cot t. Okay. Integration is over plus c. So you can mention that formula in bracket. Okay. Integral e raised to x into bracket f of x plus f dash x dx. Integral e raised to x into f of x plus f dash x dx, that is equal to e raised to x f of x, e raised to x f of x plus c. This standard formula you may have studied actually. Okay. So e raised to t into cot t plus c. Now again, we have to go back. Okay. What is our substitution? We have to say what is t? T is cos inverse x and x is cot t. So reverse it back in terms of x only. Okay, we have to reverse it back. So that is equal to e raised to cot inverse x into cot t is x, no? You see the substitution. T is cot inverse x and cot t is x. Series to cot inverse x into x plus c is the final answer. All these problems are from the last year CBSE board examination papers. Okay, different region is having different question papers actually. So I have collected from questions from the different question papers. So now take this question. Integral from the limit log root 2, lower limit is log root 2 and upper limit is log root 3. 1 upon e raised to x plus e raised to minus x into e raised to x minus e raised to minus x. It is not a direct question from the textbook actually, you know. Sometimes we may be seeing a problem first time in the question paper only. So at that time, we have to get the idea. Okay. For that, we need a lot of practice of different type of examples and problems. So that will give some idea actually. Okay. That's the only way to study mathematics. We have to practice more and more and more problems. So for every problem, we will be getting some idea. And those idea will be helping definitely in solving a new problem. Okay, have a look at this problem and get the idea what to do. If you have any idea, you can put in the chat box. Think about it. So please evaluate integration of dx by x plus 1 raised to, so x plus 1 raised to 5 into x square plus 2x. I am not able to identify read this question. So that's why I'm telling you, instead of putting in the chat box, you can write this question in a paper and you can send this problem through WhatsApp. Okay. You can send your queries, your problem through WhatsApp. You can send it to the coordinator of this program actually. Once Sari is here, so he will be handing over to me. Okay. So what we will do, first, you can see it is of the form a plus b into a minus b. The first term is a plus b, second term is a minus b. That means a plus b into a minus b is a square minus b square. So we'll apply that property. Okay, I am taking only the integral part now. Okay, limit I will write later because continuously we have to write this limit again and again. Okay, so before that, I will simplify it further. So this is equal to e raised to x a plus b into a minus b. E raised to x whole square. That means e raised to x you can write, na? E raised to 2x. E raised to x whole square means e power 2x s square minus b square. B square means e raised to minus 2x. Just applying a plus b into a minus b. Okay. A plus b into a minus b. That's all. Now what to do? This can be written as e raised to 2x all divided by e raised to 4x minus 1. Basic simplification only. E raised to 2x divided by e raised to 4x minus 1. Correct? What I have done? Normal simplification. E power minus 2x, you can write 1 by e raised to 2x. Otherwise, you can multiply e raised to 2x both the numerator and denominator. Multiply e raised to 2x both the numerator and denominator. So directly you will get this term. Now what to do? In the denominator, you can see, now you may be getting some idea. You know? This e power 4x, e raised to 4x can be written as e raised to 2x the whole square. E raised to 2x the whole square minus 1. Now I think it is more clear, na? Now I think it is very clear where to do the substitution. Where to do the substitution. So this is what we have to do actually, okay? After getting a problem, you do something, some simplification, whatever possible there. So later on, you will come to know the substitution, what is the correct substitution, etc. Now it is very clear. We have to substitute e power 2x as t. Okay. So this is equal to, let us substitute, okay? So e power 2x equal to t. Put e power 2x equal to t. That means derivative of e raised to 2x means 2 into e raised to 2x into dx equal to dt. Okay. So 2 e raised to 2x dx equal to dt. And remember, there is a limit also. No? I have not written the limit actually. The limit is log root 2 to log root 3. It is already there. Log root 2 to log root 3. So that also we will change here itself, now itself, while doing the substitution. Okay. So when x is log root 2, when the lower limit is x equal to log root 2. So what is the value of t? T is equal to e raised to 2 log root 2, isn't it? T is equal to e raised to 2x. So e raised to 2 log root 2. That means e raised to log root 2 square. That is 2 only. 2 log root 2 is same as log of root 2 square. Root 2 square is 2. So e power log 2. E raised to log 2, that is equal to 2 only. That property of log and exponential function I have already told you yesterday, day before yesterday. So the value is 2. Okay. Similarly, the upper limit is log root 3. So that also will be reducing. Okay. X equal to log root 3 implies t is equal to 3. Same procedure. No? Same procedure. 2 log root 3 means log 3. Series log 3 means 3 only. So change the limit also. Okay, everything should be in t. So limit also should be changed. So lower limit is 2, upper limit is 3. And this e raised to 2x dx equal to dt by 2. dt by 2. So 1 by 2 take outside. All divided by denominator e raised to 2x whole square. That means t square minus 1. Now you see the problem has been reduced to a simple integral. You know, the very, very fundamental formula you should know, that's all. I think everybody knows this formula. Formula must be thorough. Okay, all the formula standard integral must be thorough. So this is of the form dx by x square minus s square. Dx by x square minus s square. So what is the formula? 1 by 2a log mod x minus a by x plus a. X minus a by x plus a. Isn't it? Yeah. So here 1 by 2 already the outside. Again a 1 by 2 will come. 1 by 2 into log mod t minus 1 by t plus 1. Okay. Log mod t minus 1 divided by t plus 1. So put the limit, substitute the limit after that. The remaining you can evaluate by yourself. This is another problem from the last year question paper. So look at this problem and think about the method. Okay, what can be done here? Okay, any idea? So what we will do, we can see inside the root. In the beginning, there is an x square. And in the second term also, if you square it, again you can find an x square. X square into log x the whole square actually. X log x whole square. So x square is common for both the terms. So that can be taken outside actually. Okay. Root of x square into 4 minus log x whole square dx. And this is equal to, now what to do? Root of x square, again you can take outside, okay? So you'll get 1 upon root of x square means x into root 4 minus log x whole square. Okay, so after rewriting like this, I think now it is very clear what to give the substitution. Now it is very clear what to give substitution. Log x. No? Log x is the only option. There is no other term actually. No? So put log x equal to t. So very clearly, the derivative of log x is ready here. The derivative of log x is 1 by x. That is ready here actually to accept it. You know? So put log x equal to t. So 1 by x dx you take together. So that will become dt. So log x equal to t, which implies 1 by x dx equal to dt. And limit also, let us change the limit also. Okay, lower limit is 1 for x. So x equal to 1, the lower limit is 1. So that means t is equal to log 1. So what is log 1? 0. Then upper limit, x equal to e. X equal to e implies t is equal to log e. T is equal to log e. And log e is equal to 1. So apply these changes. This integral reduces to 0. Lower limit is 0 and upper limit is 1. So 0 to 1. 1 upon root of 4 minus t square. 4 minus t square into 1 by x dx. 1 by x dx is nothing but dt. Now I think it is clear now. Now it is a very standard integral, non-integral. To apply the formula. Okay, this is of the form root of 1 by root of s square minus x square. 1 by root of s square minus x square form. Standard integral, you know the formula. What is the formula? Sine inverse x by a formula. Okay, sine inverse x by a. Here it is t only. That's all. So in every integration, ultimately, we have to bring that expression into a known form, a standard formula form. Cos x by sine 3x dx. Another last year question. Cos x upon sine 3x dx. Any idea? Some of you may be knowing the method actually. So you can tell me the answer. You can put in the chat box. Any suggestion? So what we will do, sine 3x. You know the formula for sine 3x, the identity. You have studied in 11th class. What is sine 3x? Just apply that identity. So this is equal to cos 3x, sorry, cos x upon sine 3x. Sine 3x means what? 3 sin x, 3 sin x minus 4 sin cube x. Okay? 3 sin x minus 4 sin cube x. Now I think you can do something now. We can do some substitution because in the numerator you can see cos x. Okay. Cos x is the derivative of which term? Sin x. Now we can see everything is sin x in terms of sin x in the denominator. So if you put sin x as t, the numerator becomes dt. Isn't it? So that is the idea. So put sin x equal to t. Put sin x equal to t so that cos x dx is equal to dt. Cos x dx equal to dt. So this integral reduces to what? Cos x dx, that is dt divided by 3 sin x, that is 3t minus 4 sin cube x, that is 4t cube. Isn't it? dt divided by 3t minus 4t cube. Now what to do? The denominator is a cubic polynomial. Now, if it is a quadratic, okay, we can easily do. We know the method, but it is cubic. No? So what is the idea? So we will take the t outside. Okay, you can factorize it very easily. T is common. So t into 3 minus 4t, isn't it? T into 3 minus 4t square. Sorry, 3 minus 4t square. Now what to do? Now what I will do? Multiply a t in numerator and denominator. Okay, multiply a t in both numerator and denominator so that the denominator becomes t square into 3 minus 4 t square. Numerator is t dt. Denominator is t square into 3 minus 4 t square. Otherwise, also we can do it in another method. Okay, that is, we can factorize this 3 minus 4 t square. Okay, we can factorize and you will get 3 terms in the denominator, then apply partial fraction. That is another way. But I think this one is better. So t dt by t square into 3 minus 4t square. Now put t square equal to some new variable. Put t square is equal to u, a new variable. That means 2t dt. 2t dt is equal to du. So in the numerator, there is a t dt. So that t dt becomes half du. Half du divided by t square. What is t square? That is u into 3 minus 4u. Okay. Half into du divided by u into 3 minus 4u. Now, you know the method. It's very simple. No? You have to do the partial fraction. Anyway, any method you can do it. Better to do the partial fraction. Only two terms are there. So apply the partial fraction. A by, okay, a by u plus b by 3 minus 4u. And find a and b. After that, again, remember we have done two substitutions, okay? So at last we have to get back the answer in x. Don't forget. I think the remaining you can complete, okay? Apply partial fraction and complete. This one, x square into log of x square plus 1 dx. X square into log of x square plus 1 dx. I think no need to give the solution. You may be knowing, no? You must be knowing this method actually, isn't it? If you want the solution, you can tell me. You can put type in the chat box. If you want the solution, you type yes. Okay, I will see the poll. Yeah? If more people are demanding, then I will give the method. Otherwise, I will leave it. I will go to the next problem. I'm not getting any response in the chat box. Okay. So we will move on to the next. Actually, what to do here? We have to apply the integration by parts actually. Okay, integration by parts. First function should be taken as log of x square plus 1. First function must be log x square plus 1 and second function is x square. Then apply the integration by parts. Look at this question. Have a look on this problem. This also, I think, you will be able to do. Okay. Numerator is a quadratic and denominator is a cubic polynomial. So very clearly, the method is partial fraction method. No difficulty. Direct partial fraction method. Okay. But you should know what is the how to write the partial fraction. How to write the partial fraction for this. So what is the partial fraction for this? One a by x plus 1. No? A by x plus 1. The next term is b by x plus 1 whole square. Okay. And third term is c by x plus 2. Clear? A by x plus 1 plus b by x plus 1 whole square plus c by x plus 2. Then find a, b, c. After that, you can do the integration. Now look at this problem. Integral from pi by 4 to pi by 2 e raised to 2x into 1 minus sine 2x divided by 1 minus cos 2x dx. E raised to 2x into 1 minus sine 2x upon 1 minus cos 2x dx. I think this is a textbook problem only. Eh? So what is the method actually? Just I will give the idea. What we have to do is this 1 minus cos 2x is 2 sine square x. Okay. 1 minus cos 2x in the denominator, that is 2 sine square x. Then we have to separate the bracket term as 1 by 1 upon 2 sine square x minus sine 2x divided by sine 2x means 2 sine x cos x divided by 2 sine square x. In this way, we have to do actually. Outside the bracket, there is e power 2x, e power 2x. So what happens? E raised to 2x into 1 by 2 sine square x means half cosec square x. Half cosec square x minus, in the next term, 2 will cancel, sin x will cancel, cos x by sin x, that is cot x. Cos x by sin x, that is cot x. Now you may smell something and some formula which is similar, almost similar to a very standard integral. Just before we have used that formula for some problem. Almost say, not exactly. Okay, we have to do some more modification. Which formula? E raised to x into f of x plus f dash x. Not exactly, you cannot see exactly here, but almost the same actually. Here e raised to 2x is there. That's the problem. Okay, we need e raised to x into f of x plus f dash x form. So for that, you need a little modification. That's all. You put the 2x equal to t, 2x equal to t, and proceed. So automatically, you will be exactly getting this into that form. Okay, so do it. You can do it later. You can complete by yourself. These both problems asked in the in our question paper actually. Okay, what we have received in our Kerala, etc., in Trivandrum region, in that question paper, these questions were there. So minus 2 to 2, x square upon 1 plus 5 raised to x dx. Minus 2 to 2, x square upon 1 plus 5 raised to x dx. These are very, very special type of integral actually. We have to remember the method very, very thoroughly. Okay. For a particular integral, sometimes we have to use that particular method, that idea. So we have to be very, very careful and remember it forever. Okay. So what to do? So let us take this integral as I. Okay. I am going to apply the definite integral property. So for that, before applying the property, I have taken this integral as I. Okay. Now I am going to apply the property, one of the property. Which property I am going to apply? This property. Integral from a to b f of x dx is same as integral from a to b f of a plus b minus x dx. You remember this property? This is a property of the definite integral, isn't it? So we will apply this property here. Okay. Here a means minus 2, b means plus 2. So wherever x is there in the function, you apply a plus b minus x. What is a plus b here? Minus 2 plus 2. minus x. That is 0 minus actually. 0 minus x. Okay. So therefore, using this property, using I is equal to minus 2 to plus 2, minus 2 to plus 2. In place of x, what I have to write? Minus 2 plus 2 minus x. Minus 2 plus 2 minus x. I am writing the whole thing. Divided by, sorry, whole square is the whole square, x square, divided by 1 plus 5 raised to 5 raised to x. In place of x, write minus 2 plus 2 minus x. You don't need to write all these things. Okay, directly we can write minus x. Minus 2 plus 2 minus x means it is minus x only. Anyway. So that is equal to minus 2 to plus 2. Minus 2 to plus 2. Minus 2 plus 2 minus x means minus x whole square. That means x square only, no change. X square divided by 1 plus 5 raised to minus x. 1 plus 5 raised to minus x. You see, after applying the property, the integral reduces in this way. Now this is again equal to minus 2 to plus 2, minus 2 to plus 2, x square into what I will do? I will multiply 5 raised to x, both the numerator and the denominator. Okay, 5 raised to x multiply both the numerator and denominator. That means the denominator becomes 5 raised to x plus 1, isn't it? If I multiply, otherwise this 5 raised to minus x can be written as 1 by 5 raised to x. Both are same only. Okay, 1 plus 1 plus 1 by 5 raised to x. Again, simplify and take 5 raised to x in the numerator. You will get like this only. So directly, just multiply 5 raised to x. So 5 raised to x into 1 means 5 raised to x. 5 raised to x into 5 raised to minus x means 5 raised to 0. That is 1. So this is equation 2. Okay. Our original integral was the equation 1, given integral. Now the same integral has been reduced to a new form. Okay, put it as equation 2. So add the two integrals now. Adding the first integral and the second integral, the same integral only. That means I plus I. I plus I means 2I. Both are I. Okay, both integrals are same only I. So I plus I, that is 2I. 2I is equal to, well, now what we can see, the denominators are same. Okay, why? That is why we are adding. Otherwise, we won't be able to add. No? Denominators are same only, 1 plus 5 raised to x. In the second integral also you can see, that is also 1 plus 5 raised to x. That is why we can add it. Okay. So this is equal to integral from minus 2 to plus 2. The numerator. Numerator in the given integral it was x square. Okay. In the first integral plus the second integral it is x square into 5 raised to x. All divided by 1 plus 5 raised to x. The common denominator. Isn't it? Now what you can observe, this is equal to integral from minus 2 to plus 2. X square is common. X square is common. Take it outside. So bracket 1 plus 5 raised to x dx. All divided by 1 plus 5 raised to x. Take the common factor outside. So 1 plus 5 raised to x. Now again common for both numerator and denominator. So cancel it. So what is remaining? Only x square. Okay. So remaining is minus 2 to plus 2 x square dx. That's very simple integral. Everybody can evaluate by any method. You can directly or using formula, etc. Okay. So remaining, I think this is 2i. Okay, remember what we are finding. What we have got just now is 2i minus 2 to 2 x square dx. This is a very simple integral. You can directly evaluate. Okay. Is it clear? Okay. Evaluate. Next problem. Evaluate 0 to 2 pi. Integral from 0 to 2 pi 1 by 1 plus a raised to sin x dx. Integral from 0 to 2 pi 1 by 1 plus a raised to sin x dx. So here also we will apply the property. Okay. For that, first you put it as I. The given integral, take it as I and put it as equation 1. I think it is not a new problem. In many question paper, you might have seen this question actually. Okay, not a textbook problem, but in many books or many question paper, it is there. Okay, so put it as I. Okay, then apply the property. Which property? 0 to a f of x dx form. 0 to a. In place of a, you can see here it is 2 pi. So apply that property. So using integral from 0 to a, integral from 0 to a f of x dx is equal to 0 to a f of a minus x dx. Apply this property. Therefore, I is equal to 0 to 2 pi, 0 to 2 pi, 1 upon 1 plus e raised to sine 2 pi minus x. Sine 2 pi minus x. The property says that wherever x is there, substitute a minus x. Okay. So here the limit is 2 pi. So what is sine 2 pi minus x? Everybody must be knowing that is 0 to 2 pi 1 upon 1 plus e raised to what is sine 2 pi minus x? That is minus sin x. Okay, minus sin x. Basic trigonometry. Sine 2 pi minus x is minus sin x. What is cos 2 pi minus x? Cos 2 pi minus x is same as cos x. All these are the basic trigonometry. Okay, so what to do next? I will multiply e raised to sin x both numerator and denominator. E raised to sin x, multiply both numerator and denominator. So e raised to sin x all divided by e raised to sin x into 1 means e raised to sin x plus 1. Isn't it? Just like in the previous question. Or otherwise, this e raised to minus sin x can be written as 1 by e raised to sin x. Okay, then cross multiply, take e power sin x in the numerator. Directly, you just multiply e raised to sin x, so you will get the expression as it is, as in this form. So now put it as equation 2. This is our equation 2. Okay. This is also I, remember, this is also the same integral I. After applying the property, we are getting into another form. Now you see the original integral. Original integral, what is the denominator? Denominator is again same, 1 plus e raised to sin x. Okay. In the new integral, that also the denominator is same, 1 plus e power sin x. So just let us add it. So that means 1 plus 2. Equation 1 plus 2 implies 2i is equal to integral 0 to 2 pi. Okay, denominator is same. Denominator is 1 plus a raised to sin x for both. So just add the numerator. Numerator 1 in the first integral and e raised to sin x in the second integral. Isn't it? So 2i is equal to 0 to 2 pi 1 plus e raised to sin x upon 1 plus e raised to sin x dx. So now it is over now. Both will cancel. So 1 dx remaining, integral of dx, that is x actually. Then substitute the limit, and you will get the answer as 2 pi. And this is 2i. So 2i is equal to 2 pi. That means I is equal to pi. Okay. Now we have only 5 minutes left actually. Okay. So just look at this problem. You can take it, note it down. I think you can do it very easily. What to do? The numerator degree is 4, denominator degree is 3. So naturally, definitely, we have to divide the numerator by the denominator. Okay. The division can be done by any way, usual division or some other shortcut method also you can apply anyway. Okay, division can be done in this way also. Okay, some arrangement you can do here. For example, this x power 4, I can write x power 4 minus 1 plus 1. I will add a minus 1 and plus 1. Okay. So that means the next step, x power 4 minus 1 can be factorized. X square minus 1 into x square plus 1. Okay, plus 1 all divided by x minus 1 into x square plus 1. So we can separate it. Okay, you can separate it as two terms. So in the first part, this x square plus 1 will cancel. Okay, x square plus 1 will cancel in the first part. So remaining will be x square minus 1 by x minus 1. And again, x minus 1 will be cancelling. So you will get x minus 1 only remaining, x minus 1. Okay, in the first part, plus 1 divided by everything as it is. Okay, x minus 1 into x square plus 1. Actually, this is a division only, but we are doing in a shorter way, shortcut method. That's all. Okay. So after division, any way you divide it, you will get like this. First term is x minus 1 plus 1 divided by x minus 1 into x square plus 1. For the second part, you have to apply the partial fraction. Okay. The next, this also I think there is no need of any explanation. It is a textbook problem only. Okay. The sine 2x, you have to write 2 sine x cos x. Okay. 2 sine x cos x. That's all. Then sine x, you substitute as t. In place of sine x, you give the substitution t. So cos x dx will be dt. In this 2 sine x cos x, there will be a cos x, and that cos x dx becomes dt. Isn't it? So you can do it. Okay. Now the time is already 4 o'clock. So it is the time to stop our class actually. So if you have any doubts or any clarification is required or any problem is there, you please send through WhatsApp. Okay. You write in a paper and send through WhatsApp. So we'll stop here. Okay. Thank you. Again, we will meet in the evening 6:30.